Welcome to the DX NetOps Network Monitoring Software Overview course. So the reason why we are developing and unifying the DX NetOps platform along with integrating digital experience monitoring from AppNeta is because of the evolution of networks and how they are shifting over the years. I think we all know whether it's the pandemic, whether it's cloud adoption, SaaS adoption, SD-WAN adoption, the user experience does not exist within the four walls of the data center anymore. It exists over managed and mostly unmanaged networks like the internet, like cloud providers, etc. Users are working from anywhere, working from home, in and out of the office. Resources are in cloud providers, in SaaS providers. They don't exist solely in the data center anymore. And this is why we say the internet has become the new enterprise network. Whether network operations teams realize it or not, if they're responsible for network delivery for any of their users over this new evolving networks like home Wi-Fi, internet, all the way out to cloud providers, they're responsible for that entire network path, whether they own it or not. So if we look at what the DX NetOps network monitoring platform looks like and how robust it is when it comes to full stack monitoring, as we can see, we have comprehensive multi-vendor coverage for any part of the network, including any network metric that needs to be collected in order to understand and deliver valuable insights back to our network operations teams. So whether it's home Wi-Fi or branch offices, mobile, inside of corporate data centers, whether it's WAN or SD-WAN or out into service provider networks, hybrid cloud environments, whether it's software-defined data center deployments and even into public cloud environments. Our coverage for network operations is immense, as well as the capabilities to manage every part of the network for any role or responsibility within our customers' network operations teams, whether it's a level 1 NOC operator, whether it's a network admin, network engineer, network architect, or planner. Customers and users of the DX NetOps platform have accessibility to easily surface metrics for very quick triage and troubleshooting of issues, or a level 2, level 3 NOC operator, network engineer, network architect, if need be, can dive deep into granular latency, packet loss, capacity-related metrics to understand very particular information about what is going on inside of a network degradation that's affecting the user experience. So if we break this down and look at fault management, we all know that DX NetOps Spectrum is part of the entire DX NetOps platform. Many decades of patented and recognized fault management. Just some of the marquee features and capabilities are listed here, whether it's discovery and topology, very popular configuration management functionality and capabilities, whether to understand when someone has fat-fingered a configuration on a network device, rolling that back, understanding where that misconfiguration is inside of the known good state of a router or switch or network device configuration, and then rolling that back for minimal or even preventing outages. Of course, root cause analysis, alarm noise suppression, all to understand where a network fault is, what its impact is on its neighbors, and how it is affecting the user experience. And then when we look at DX NetOps performance, of course, fault and performance go together to understand agnostically multiple vendors collecting enormous amount of data, correlating that data, cleaning that data, normalizing that data across multi-vendor technologies, but presenting it in a unified, easy to understand fashion for our customers and network operations teams today. What does the performance of network delivery look like when it traverses over my Cisco gear, but then moves into my VMware virtual instances, maybe goes into a Juniper firewall and out into an internet service provider? What does the performance of that entire network delivery path look like? Of course, proactive and predictive insights from the data collected on networks today to understand capacity-related issues, to understand any baseline or deviation from normal behavior, understand what packet loss or latency might look like today versus what it may be moving to 30 days from now, 60 days from now, 90 days from now, etc. All valuable network performance information out there. And then, of course, full stack wouldn't be complete without flow data. So understanding from network flow analysis what network traffic looks like, its composition, its behavior, what applications are using the most bandwidth on the network, identifying those applications, identifying those users, being able to understand how efficient the network is delivering those applications. Even understanding capacity for future growth of those applications that may be using a lot of network bandwidth. And then, of course, all of that fault performance flow for new software-defined technologies. So taking everything I just talked about in traditional networks and then applying it with virtual network assurance to software-defined stacks like Cisco ACI, like VeloCloud SD-WAN, Fortinet SD-WAN, network functions virtualization, cloud-based Wi-Fi like Aruba, etc. So doing everything we've done in traditional networks and applying it to software-defined networks, whether it's fault, whether it's root cause analysis, whether it's alarm noise reduction, whether it's SD-WAN, pinpointing and using collected metrics inside of software-defined technologies, and understanding from a network operations point of view, how are those software-defined technologies delivering the user experience across these new architectures. And then finally, with the AppNeta acquisition and first integrations of AppNeta information and metrics inside the NetOps portal, being able to understand what the entire network path looks like from the start of it and true end-to-end. Maybe it starts inside of the data center and ends up out into the cloud, or it starts from a work from home. And understanding that entire network path, the health of that network path, taking this network experience delivery path information from AppNeta and applying it to what performance of those network devices within that path looks like, and surfacing that information for immediate root cause of the entire network path experience and any degradation or issues within that. The great thing about AppNeta, it definitely differentiates itself and delivers very exciting capabilities to the entire NetOps family of solutions here. Whether it's synthetic transaction monitoring, whether it's active monitoring of the entire network path to understand and isolate any points of degradation inside the entire network path, again, across managed and unmanaged networks like ISP and cloud providers. And then being able to use this information to quickly identify and isolate root cause, and more importantly, identify the innocence of the network operations teams and put the ownership of this degradation issue on the ISP or cloud providers. So this is what the entire solution looks like from a full stack visibility perspective across any type of network out there that our customers are using today. And what does this mean? This is what the solution achieves for visibility when it comes to understanding true end-to-end network delivery performance and validation. Wherever the transaction starts, again, it could be from a work from home environment, it could be from a non-office like a coffee shop, could be in the corporate environment, it could be branch offices. Being able to understand and visualize every single hop across old and new network architectures to easily identify and isolate points of degradation to quickly troubleshoot and bring back what should be an exceptional user experience. And like we say here, NetOps teams are now responsible for the entire network delivery path of the user experience, whether they own the infrastructure or not. And Broadcom's NetOps solutions, including AppNeta, completely deliver visibility into every single hop so they can understand performance degradation at any level. So when we look at the latest release of DX NetOps with its first integrations of AppNeta user experience data, we help our customers innovate at speed. We are the only vendor out there unifying coverage for the most modern software-defined technologies across many, many different vendor landscapes. So our network operations teams don't end up being the bottleneck when it comes to new software-defined deployments. They're ready to manage it day zero, even day one. And then being able to understand network path and the entire end-to-end network delivery along with network device performance data, so marrying that information. This enables us to route user experience metrics from AppNeta through our customers' standardized operating procedures and workflows in a single tool. So to be able to utilize standard operating procedures when it comes to triaging and diagnosing network performance issues, to have network path experience metrics and user experience metrics, to be able to get even more granular insight to what network delivery looks like and performance, helps to transform operations triage and response. And then again, being able to protect the digital experience and the network delivery of that digital experience. We are the vendor with the highest monitoring scale in the industry today, combined with AppNeta's active testing of the entire network delivery path for complete end-to-end visibility and isolation of any performance degradation inside of managed and unmanaged networks today. When it comes to new software-defined technologies, I do believe Broadcom has the most coverage for the most software-defined vendors out there today. We have many customers that have more than one software-defined vendor in their organization delivering the user experience. And it's very important to understand that the software-defined network path is not from edge to edge. The software-defined network delivery experience over WAN starts well inside of data centers or branch offices and then uses the edge software-defined WAN infrastructure to continue along that path, and then, of course, ends up inside of some type of cloud, SaaS, corporate data center, and continues along inside of that corporate infrastructure, touching many other different network devices, which is why you need visibility beyond the edge. Edge-to-edge visibility for SD-WAN is not enough. End-to-end visibility of the entire SD-WAN network delivery path is what is important. And that type of functionality and capabilities results in these types of use cases and workflows. So being able to validate and continually test end-to-end performance of new SD-WAN deployments that are delivering critical user experiences. As standard operating procedures inside of network operations today dictate, you start with an alarm. From that alarm, you easily are able to understand the health of the entire network path over SD-WAN. This information is surfaced very easily and quickly to isolate what areas of the network operations should focus on when it comes to troubleshooting. And then moving into more granular information, what does network latency or packet loss or capacity or jitter look like over that affected network path? And then getting even more granular with AppNeta data to understand what every single network hop and the performance at that hop looks like along the software-defined network path. Other great use cases that the entire NetOps and AppNeta solutions provide around optimizing operations, being able to help our customers unify access of the entire full stack network of fault performance flow, you name it, but along with user experience metrics now from AppNeta, having that entire picture of what network performance looks like from every single available metric that can be collected, correlated, normalized, and then surfaced in an easily digestible manner like we see here. We start again, always from an alarm that has come in. As we can see, we can acknowledge this alarm. We can assign a troubleshooter. Following standard operating procedures, we can use typical network triage and troubleshooting steps like pinging and trace routing, and even creating a ticket, opening up a ticket in an external third-party help desk application is always important at your fingertips. Being able to understand network performance, high utilization, bytes in, bytes out, capacity, what the entire network path utilization looks like, inbound, outbound, again, along old and new software-defined technologies. And then even being able to understand what the symptoms of the problem is, the probable cause, and recommended actions to take to resolve it. This is what unified visibility of the entire network stack along with user experience network delivery metrics looks like. Collecting as much information as possible is important, but displaying and focusing on the right information for network operations teams is more important. We don't need to display every single piece of metric and data that we collect along the network. We just need to focus network operations teams on what matters, and not chasing network blips or high utilization of a network device that isn't passing important user experiences. And then finally, what does protecting the digital experience look like? Our network operations teams need real-time end-to-end visibility into the remote user experience, even if it traverses over ISP or cloud networks. Again, starting from an alarm. This alarm could have been created from thousands or tens of thousands of events, but as we know, the patented alarm noise reduction inside of DX NetOps fault solution, we know as Spectrum, is able to just surface and focus operations attention on one alarm that has removed all the noise of the tens of thousands of events that created that alarm. So again, starting from an alarm, easily moving into the health of what that entire network path looks like, even if it starts at a work from home environment. Understanding green, yellow, red, what looks healthy, what do I need to focus my attention on. Understanding from AppNeta data what that entire digital experience looks like from a network delivery, hop by hop standpoint, and identifying right away, isolating the device or devices. Here we see this is an ISP device with a threshold breached of data loss. So immediately understanding an excessive network path change alarm has come in. We then move to what the network path looks like from a health standpoint, and we've easily then understood and isolated the specific network device inside of this ISP network that is affecting the user experience. And then, of course, capacity, jitter, voice, data loss are always important metrics to surface to reinforce that we do understand that this is the culprit device, taking this information back to ISPs so they can fix it immediately. And then finally, I just want to highlight how important it is to collect as much information, even if it means collecting network performance metrics over some of the largest networks out there today, like our telecommunication providers or our government facilities. But if you're just missing one of these metrics, you're not going to be able to have full visibility into what network performance and network delivery looks like of the user experience. And I'll give an example. So let's say you are collecting user experience metrics, alarms, performance, fault, flow, logs, and maybe you're doing a little AI, but you don't monitor configuration changes. Well, if you have a performance degradation or a device that has gone dark or isn't pingable anymore, and that was because a network engineer fat-fingered a configuration during the day and brought that device down, is not able to route traffic anymore, then you're going to spin your wheels and spend a lot of time looking for the needle in the haystack, when if you were monitoring configuration changes and had automated identification of those changes and rollback procedures, you could have prevented an outage. Another example, maybe you're collecting all this information but aren't really looking at logs, and the identification of performance degradation was only visible inside of a device log. Maybe a interface on a switch is flapping or is having a hardware issue inside of it, and that is only represented in the log of that device. If you're not collecting logs, or at least doing detailed log analysis, anomaly detection, pattern recognition, this is something that, again, you would spin your wheels on, not knowing it was a hardware issue on a interface on a switch, and maybe was looking at the overall performance of that switch. This is how you're able to isolate, quickly troubleshoot and triage what could take hours, if not days, and turn this into a few minutes of troubleshooting. We've had customers who went from days of troubleshooting down to minutes of troubleshooting because of the full visibility picture we give them when it comes to the amount of metrics and data we collect on today's very complex network infrastructures.